No duration. No duration.
Pardon? Can you repeat that?
No duration. Rotation.
No?
Rotation. No rotation. No rotation.
Okay, no rotation because of restoring moment.
Yes.
Okay. So for today's session, after we learn about the stability, and then the stability also include the buoyancy. All right. So you need to know what is the buoyancy. Buoyancy is the force acting on the object in the vertical upward direction, where it will involve the displaced liquid. All right. So you need to consider the displaced liquid only when involved of the buoyancy force. Okay, so for today's session, we're going to cover the linear accelerating container. All right. Okay, I believe you have print out your lecture note. All right, this is already posted in the e-learning. All right, this is week 5, lecture 2. All right. So this is the linear accelerating container. So what it means by linearly accelerating container. All right. So where is the container? This is the container. Okay. Inside the container, we have the fluid. All right. In this section, the fluid will be at rest relative to the reference frame. All right. So now we consider our reference frame is this container. So why this fluid at rest? Because we are reference or relative to the container. The container relative to the fluids. So we consider this fluid at rest. Okay. That is linearly accelerating with the horizontal component AX. So that means the motions of the container in this direction. Okay. In this direction. Alright. So this container have the acceleration. Okay. In this direction, we can separate into two components, which is AX. This is the total acceleration, and AZ. Okay. Consider that we have the coordinate system. This is our coordinate system, X, Z, and Y. Alright. So do you think what's the other component that that not involved in the motion? Can you guess any other component that do not involve in the motion? Everyone, are you there?
Yes, Doctor.
Okay, which component do not involve in the acceleration or in any kind of motion? So can you see this is Y axis?
Y.
Do you think the Y axis involved in the acceleration or any kind of motion? No, right?
No.
Because this container is in this kind of motion. Alright, there is no sideway of motion. It is a straight of linearly motion. You can see here. Okay, so for this case, we only consider the X component and Z component. Okay, so now you understand, yeah, the horizontal component as well as the vertical component. We call as AX and AZ. Alright. So far you understand, yeah, this concept of container. The container moving in this direction with the acceleration in X and Z component. Okay, because of this motion, the water inside the container will form this kind of shape. Alright, this is the natural condition. Okay, because of the acceleration, the triangle shape. Alright, so equation 236 simplify to, okay, this equation is actually the pressure linearly with the depths. Alright, the pressure directly proportional to the depths. Okay, this is what I explained to you the last lecture where we use the hydrostatic force. Remember, P, the change of P equal to negative gamma, the change of H. Do you guys still remember this kind of hydrostatic equation? Okay, that we use to measure the manometer? Do you still remember, everyone?
Yes.
Yes, yes, sir.
Okay. So this is hydrostatic equation that we use this kind of equation frequently to measure the change of pressure from this point to this point, A to B. Alright. So because of this equation, we can do the more application based on this kind of equation. Okay, this is the simplified equation, right? Yeah. Okay, let me delete that. Okay. So please write it down. Okay, this equation based on the book of Potter. Right, the change of P equal to negative. Can you see? Negative rho A. This is acceleration A dx minus rho AY dy minus rho AX, sorry, AZ plus G dz. This is equation 2, 3, and 6. Okay, this is from a Potter book. All right, if you look at Potter book equation, this equation, you will find this equation. Okay, since we are not involved in the y component, right? We are only involved in the x and z. The y is not involved in this case, as you can see in this kind of motion. So we can omit the value of y here. We can cancel. So what we have here, okay, we're gonna have dp, the change of pressure between 2 points, let's say point 1 and 2, the change of pressure equal to the same thing, negative rho ax. This is acceleration in the x component, dx minus this kind of term, rho g plus, alright, okay. So you can have the same thing. Okay. Ax, alright, Az plus G dz. So this equation, we let's say equation 2, 5, 1. Alright. Okay, this equation based on the chapter 3. Okay, this is chapter 5. Alright. So from chapter 3, we explore further this kind of equation and lead to this equation where we simplify into this kind of terms. All right, we consider x and z component. Okay. So from equation 251, integrate between 2.1 and 2 because we have 2 point. We can do the integration because we have the differentiation. Okay, we can do integration both sides. Okay, so let's say this is point. Okay, point 1 to point 2. Point 1 to point 2. So once we do the integration of integration with differentiation, we can cancel each other. We will lead to this equation. Okay. We will got this equation P2 minus P1 equal to the same thing. Alright, but the difference is x. x2 minus x1. Okay, x2 minus x1. Alright. Rho, this is the fix. Alright, this is constant. Okay. Okay, z2 minus z1. Okay. Let's say this is equation we call as a 252. Alright, from this equation we extend. This is 1, this is become 2. This is after integration. Okay, this is after integration. We got this equation. Alright, if point 1, can you see here? If point 1 and 2 lies on the constant pressure line, that means point 1 and 2 will have the same pressure point. Maybe this is 0, this is 0. Can you see this is the free surface on top of the water? Alright, then P2 equal to 0, P1 equal to 0. Then what we have here, we can cancel out this term because this is equal to 0. And then we can rearrange this equation. We will got the final equation equal to z1 minus z2 over with x2 minus x1, right, equal to, okay, tangent, sorry, equal to a x over plus az plus g. Okay, this is what we rearrange this equation and lead to this equation. Okay, from this equation we realize that z1 minus z2. Okay, z1 minus z2, we got this kind of length, right? Okay, z1 minus z2. And you can see here x2 minus x1. Can you see? x2 minus x1. We got this length. So what do you think can we do from here? Let's say this is alpha. We got this length.
From Pythagoras? No.
We can use the Pythagoras Theorem. Okay. So what can we relate delta x and delta z? Which
Alpha.
one?
Tangent?
Okay, tangent. Alpha equal to
Delta Z
over delta
over
X.
delta X.
Delta X. So this term the same with this, right? So we can simply put here equal to tangent alpha. Okay. So can you see where is alpha? Can you see now? This is alpha. So this is our equation. Alright. Simple. This is our simple equation. Z1 minus Z2 over with X2 minus X1. Okay, for those difficult to remember, I will give you one tips. Okay, let's say this is A, this is B, and this is C. This is alpha. Okay, how to get tangent alpha? Which one minus? Everyone, how to get tangent alpha? The change of this one, right? A, B. Okay, for this case, A minus B or B minus A? Everyone, are you there? A minus
B.
A minus B. Why A minus B? Why A minus B? Okay. First, what you need to do, you need to have a reference point. Okay, let's say this is your point. This is your reference point. Okay, on top of B, is it positive or negative? Above B.
Positive.
Positive. That means A minus B. You want to get positive, right? Okay. This is opposite and this is adjacent. Okay, how to get the positive of denominator? B minus C or C minus B?
B minus C.
Pardon?
C minus B.
C minus
C minus B.
C minus B or B minus C? How to get positive? Okay, this is your 0. Okay, to the right is positive or negative?
Positive.
Positive. That means C minus B or B minus C?
C minus B.
C minus B.
C minus B.
Minus B.
Okay. Okay. Now you understand? Okay, let's say this one. Tangent alpha. Okay. This is... Okay, this is... Let's say this is Z1. This is Z2. And then this is X1. This is X2. Okay, how to get tangent alpha? Z1 minus Z2 or Z2 minus Z1? How to get positive?
Z1 minus Z2.
Okay, can you see here? Alright, over with adjacent. Z1, X1 minus X2 or X2 minus X1 to get positive.
1 minus 2. Z1 minus Z2.
Okay, anyone? How to get the positive?
X2 minus X1.
Okay, why X2 minus X1?
Because X1 is 0 and X2 is positive.
Yes, correct. Can you see here?
Yes, doctor.
Okay, then you see here. Alright, so you can have two equations. Z1 minus Z2 or this length, simply this length and this length, sorry, equal to tangent alpha or AX. Okay, this is contra. For this case, tangent alpha equal to, okay, can you see this is opposite? Opposite is supposedly exact. So for this one, you try to inverse, okay? Okay, this is opposite, this is adjacent. If in terms of acceleration. Okay, so in terms of adjacent, this is x component. So this is ax. In terms of opposite, this is az plus g. Okay. This is how to remember this equation. Okay, everyone. So far, do you have any question? All of you? Are you there, everyone?
Yes, Dr. Yes.
Yes, Dr.
Okay. I give you one example. Can you try first? I give you 1 minute. Okay. Can you try first how to answer this? Okay, the tank shown in figure here is accelerated to the right. Okay, from the left to the right. Calculate the acceleration Ax needed to cause the free surface as shown in figure here B to touch point A. Alright, and then to cause the free surface, this endpoint will touch point A. Also, the question asks, find the pressure at point B and the total force acting on the bottom of the tank if the tank width is 1 meter. Okay, that means the width is 1 meter. Okay, let's say this is 1 meter. Okay, 1 meter. So, how to solve this equation? Okay, can you write it down, the equation first, the formula? Okay, first when you read this one, you need to determine what kind of chapter. This is acceleration. Can you see this? Alright, acceleration. So, and then can you see this is in terms of container or tank, any kind of closed that carry the water. So definitely this is under chapter 5, alright, week 5, that you're going to learn the linear accelerating container. Okay, so based on this one, after you find out that this is chapter of linear accelerating container, you need to write down the formula. Okay, step 1. What's the formula that we're going to involve? Definitely tangent alpha equal to, can you help me? Everyone?
AX.
Okay, delta, let's say delta Z over delta X equal to, okay, in terms of acceleration, okay, the top one will be AX and the bottom one will be
AZ.
AZ plus, we
G.
have the gravity. Remember, we have the gravity, accelerating gravity. So we need to include that. Okay. And then we also have another equation. Remember that this equation 252. Okay. We also have another equation that we're going to use, which is P2 minus P1 equal to negative rho AX X2 minus X1 minus rho A Sorry.
Doctor,
Yes.
I'm sorry, I still can't understand the question. What does it mean by the free surface will touch the point A? I can't understand it still now.
Okay. Can you see here? The tank shown is accelerated. Okay, from point A to point B.
Yeah.
This is before. This is after. Point
Yeah.
A is before. Point B is after. Due to the acceleration, you can see this water surface on top of water become this shape.
Oh, okay.
Okay, so find the acceleration to cause the water surface touch point A. Okay, find the linear acceleration AX to cause the free surface touch point A. Okay,
But
now
it's
you understand.
it's already touching point A, I think. Or does it mean the water to be a straight again, like previous?
Pardon? Sorry.
What does it mean? What does it mean by to touch point A? Like it's already touching point A, right?
Okay, and then okay, calculate the acceleration. Okay, can you read first and understand on your own?
Okay, I'm trying. I've been trying it. I'll try it again now. Then.
Okay, what do you understand?
Okay, it's asking to calculate the acceleration to cause the free surface, but I can understand to touch point A. Isn't it already touching the? Isn't the water already touching point A?
Okay, it is not already. Before, it is like this. Due to the
Yeah.
acceleration, it
Okay.
will cause this free surface touching point A.
Okay. Okay. Oh. Not. Yeah.
So, okay, got it?
Yeah. Now I understand.
Okay, how to get the acceleration? So we need to use this formula. Tangent alpha equal to the change of z over change of x equal to ax over az plus g. And another equation, P2 minus P1 in this equation. Okay, so the first step, we need to find the, can you see here? We need to find the x first. Okay, why we need to find the x? Because we're going to include in this equation. Once we know this x, we know this height, we can get the tangent alpha. Okay, got it? Got it, everyone? Okay. So this height we already know, which is 1 meter plus 0.2, which is 1.2 meter. Okay, in order to get tangent alpha, which is opposite 1.2, divide with adjacent, which is the x here. Okay, so now our mission, or our step, we need to find the value of x. So how to find the value of x? Okay, we can use simple equation here. Alright, step number 2, we can make the volume before equal to volume after. This is volume of air, right? Sorry, this is volume of air. Volume of air before equal to volume of air after. Okay, this is before. For this case, this is before. How to get the volume of air? Okay, this is air. What's the volume of this? 1 meter. Okay. Sorry. 1 meter multiply with
0.2
0
multiply with 2.
0.2 multiply with 2. Okay. After, how to get this volume of air? The formula of triangle. Half, remember? Okay, multiply with, what's the length of this? X, right? Okay, X. Multiply with the height. What's the height? 1.2 meter. Okay, can every one of you help me to find the value of X?
0.67.
Okay, right. 0.667 meter. Okay, once we got the value of X, what we need to do further? Anyone? Step number 3. Any idea?
Find
Yeah,
alpha.
can you see here? Tangent alpha equal to 1 over 1.2 divided with X, which is 0.667. Okay. So what's the value?
Uh, 60.94.
Pardon? I'm not asking the alpha. I'm asking the tangent alpha. I want you to solve this one only.
1.799.
Okay, 1 point, simplify 1.8 only. Okay. So, after you got this value, can you try to relate to this equation? Okay. Step number 4, you know already tangent alpha, which is 1.8. You need to relate to this AX because you need to find X, right? So AX over AZ plus G. Okay, anyone? Can you help me to simplify? Do you think we have the acceleration in Z component? AZ component. Can you see here? What kind of
No
motion this?
acceleration Z.
Right? Can you see here? Do you think this motion involved in the Z direction? Okay, this is our coordinates.
No.
No.
No acceleration, doctor. In Z.
Acceleration only in the x-axis.
Only the X axis, right? So the acceleration in the Z equal to 0. We are not involved in the Z direction. So this one cancel. So what we got here is 1.8 multiplied with gravity equal to A Z. So sorry, AX. Okay, what's the value?
17.66.
17.64.
Yes, 17.66 meter per second square. Okay, so far you guys understand until step number 4.
Yes, doctor.
Okay, so now we already answer to calculate the value of AX, which is 17.66 meter per second square. So the second question asks, find the PB, the pressure at point B. Okay. Okay. Okay, what do you think of pressure at point A? Anyone? What do you think of the pressure at point A? Is it equal to 0 or not?
Zero. Yes, zero.
Zero.
Remember
Atmospheric
that
pressure.
when this is the free surface, when the pressure on top of free surface, what do you think of the pressure here? What do you think of the pressure here? Is it equal to
Atmospheric pressure.
pressure?
Zero.
Pressure at the free surface is equal to 0 because now we consider as the gauge pressure. Alright, we assume this one to be atmospheric pressure negligible. Okay, so for this case, the pressure at point A is equal to 0 because why? Because this pressure on top of the free surface, so it is 0. What do you think of pressure at point B? Do you think there is a pressure at point B, everyone?
Yes.
Yes. Why we have the pressure at point B? Because we have the depths of water. Can you see here? Okay. So from here, okay, to here, we have the pressure prism. Okay. This is 0. So how to get the pressure at point B? What we need to use? What kind of equation can we use, everyone?
Rho Z is.
Can you see this one, the second term? Okay, you cannot use this pressure. I know already. Gamma H A, right? Because this is accelerating. Alright, this is static. Okay, now you understand. For this case, this is accelerating, having a motion. So we need to use this equation. Okay. So point pressure point 2 minus pressure point 1. Let me delete that. Okay. So we need to use this equation. Okay, step number 5. Okay, we use this equation. P2 minus P1 equal to, okay, equal to negative rho A x x2 minus x1. Okay, do you think we need to consider these kinds of term, everyone? What do you think of this term? Everyone, are you guys there or? Okay.
Yes, Dr.
What do you think? What do you think of this term? What do you think of this term?
Is it is 0?
Zero, I think zero.
0. Why 0? Is there any motion in the z direction?
No, any motion, I think.
Can you see only x component? So z2 minus z1 equal to 0. So we can out this term. So what we have here, only this simplified equation. Okay, so far clear?
Yes, doctor.
All right. So, okay. So now we can relate point A and point B. Okay. Let's say P2 is point B minus PA equal to negative rho AX. This is 2, this is 2. Definitely this is B. Sorry. Okay, we consider point A and point B. Why we consider point A and point B? Because point B definitely we going to get the answer, and point A we already know it is equal to 0. Okay, the pressure at point A equal to 0. So from this equation we already know that the pressure at point A equal to 0 because on top of free surface, and we consider this as the gauge pressure, not the absolute one. So we can cancel out this one. We got PB equal to negative rho of water, which is 1000, multiplied with the AX that we got earlier, which is 17.66 meter per second squared. Okay, multiply with the XB minus XA. Okay, what's the value of XB? This is the displacement we consider as the coordinate point. Okay, let's say this is our coordinate system. In here. Okay, this is point origin. This is our reference. So what do you think of XB? XB equal to, this is origin, right?
0.
So XB equal to?
Equal to 0.
So what do you think of XA?
XA is 2.
Equal to 2. Okay. So you need to substitute the equation. XB equal to 0 minus XA equal to 2. So you will get PB
35200.
Yes, perfect. 35.3 kilo Pascal. Okay. So from here, you already got the PB. And finally, the question asks the total force acting on the bottom of the tank. Okay. To find the total force acting on the bottom of the tank, we realize that the pressure distribution is decreasing linearly from P at point B here. Okay, we realize that the pressure on top of here decreasing linearly. Okay, that means this pressure at point A equal to 0. This pressure at this point PB equal to 35.3 kilo Pascal. It is decreasing linearly because this is exposed to the free surface. Okay. Hence, we can use the average pressure over the bottom of the tank. Okay, we can use the average pressure because this is linearly decreasing. So step number 6, okay, we can use the average pressure over the bottom of the tank. Okay, so we know already force is equal to pressure multiplied with the area. Alright, so we can use the average pressure. So average pressure is PA plus PB over 2 and multiply with the area at the bottom of the tank. So pressure at A equal to 0 plus pressure at B equal to 35.3 kilopascal over 2 multiply with the area. Okay, area of the bottom tank. So what's the area of the bottom tank here? Anyone?
2 times 1.
Yes, perfect. 2 times 1. Right. So the final answer would be 35.3 right kilo Newton. Okay. So far you guys understand, everyone? Do you have any
Yes,
questions?
doctor.
Okay.
Yes, doctor.
All right. I think the last minute here, I would like to revise one thing. Okay. I would like to ask your understanding. Okay, this is the water. And then we have the sphere here. Okay. We have the sphere, the ball. All right. What do you think of the projected horizontal, everyone? This is the force on the curved surfaces. What do you think of the projected horizontal? Okay, where is the horizontal? This one or this one? Definitely this one, right? This is horizontal. Okay, this is vertical. So what do you think of the projected horizontal? Will be this way. Okay, when you look at a projected horizontal, okay, your eyes should be like this. So what do you think of the shape here of the projected
Square.
horizontal? Pardon? Pardon everyone? What's the projected horizontal punya shape? This is the ball.
Square. Rectangle.
Okay, I think for those answer rectangle, maybe you memorize, you hafal. You need to understand. Can you, why,
No.
okay, why rectangle? This is ball. Can you imagine? Can you use your imagination? When you look at from this side, what do you think of the shape? Is it rectangle from the
No.
ball?
No,
So what's the
circle.
shape?
Circle.
Circle. Okay. So what do you think of the vertical projection? What's the shape of the vertical projection? Is it rectangle? Circle, right? Okay. Same, circle. Okay. What do you think of this? This is just to differentiate. Okay. This is the I think like this lah. Okay. Right now, I try to cut this ball. Okay, I try to cut this ball. Okay, in this Okay, I only consider this shape only. This one I remove. Okay, what do you think of the projected? This is removed, yeah? Okay, for this case, I try to make it like this. Okay, what do you think of the horizontal projection? Shape. Horizontal projection. Where's your eyes? This is your eyes outside of the ball. What do you think of the projection? What's the shape of the projection?
Hemisphere.
Okay. Why hemisphere? Because you use your imagination, right? You will look like this. Okay. Now understand. Hemisphere. Okay, like this lah. Okay, what do you think of the vertical projection? What's the shape of vertical projection from here? What's the shape of vertical projection?
Circle.
Circle. Okay, look again. This shape. This is your eyes. What you look from the bottom and from the top?
Half.
Hemisphere, right? Half, right? Okay. So because of this, you can use the value of centroid 4r over 3 pi. Okay, the same thing. Centroid is equal to 4r over 3 pi. Okay, that's all. Because for this part, it seems that some of you confused because most of you said that this is rectangle like this. Not necessary, yeah. Okay, it depends on the shape. Okay, if this is the ball, you look at from the horizontal and vertical projection, it will be like this. Okay. Okay, I think that's all. This is the attendance again. Please do scan your QR code before we end our session. Okay, done everyone? Have you?
No yet, doctor.
Okay, because I cannot generate the code after 2 p.m.
What is section 1? Okay.